All right, guys, looking at pre-calculus 2-2-1. So we're going to be talking about what's called the unit circle today. So it's going to be a pretty important topic for the rest of the year and into next year into calculus. So the unit circle is effectively a circle that has a radius of 1 unit. We do that just to keep things simple so that we can kind of scale it up or down however we need. So first of all, we're going to be creating 30, 60, 90, and 45, 45, 90 special right triangles. And we're going to do ones of those which have a hypotenuse of 1, because then that's going to match up with the radius of 1 on our actual circle here. So I normally would be giving you out a handout for this, but since this is online, we're going to have to I will do it just to kind of demonstrate what is going on. So we're then going to want to, I'm going to kind of go over all the different steps here, then we'll do it all on the document camera. So we're going to label the special right triangles. I've already done that just to kind of save time, and then we're going to label all of the angles on our unit circle. So all of these are in radians, and then we're going to find the x and y coordinates of each of these points using those special right triangles we just found. And they're going to be looking for any patterns as we're kind of going through this. Keep an eye out for any kind of pattern of, hey, I've seen these numbers be a 4, what pattern is causing that and why? So that I want you to kind of keep an eye out as we go through and do this. So I have here my unit circle. So our unit circle will always start at the origin. So its center is at the origin. So I have my positive x-axis, negative x-axis, positive y, and negative y. So there we go. Now I went ahead and I drew out our special right triangles here. So we have our 45, 45, 90, and our 30, 60, 90. So the hypotenuse is 1 on both of these. So if we do that, and then we do a little bit of Pythagorean theorem or right triangle trig, we can find these side lengths. On this one, it's square root of 2 over 2. And over here, it's 1/2 and square root of 3 over 2, or you'll hear me say rad 3 over 2 and rad 2 over 2. So before we get there, though, let's try and label all of the angles. So this is my 0 radians angle. Not too bad. Then this is pi radians, as we've discussed, right? So then if that's pi, well, this is half of a pi, or pi over 2. And then down here, this would be pi plus another half pi, or 3 pi over 2. And then if I go all the way back to a full circle, that's 2 pi. So I kind of put those two together because it's 0 or 2 pi depending on if you haven't moved or you've gone one full rotation there. Well, then I can go kind of halfway here and say, well, then half of a half is a fourth. So this is pi over 4. And then, well, then this would be fourth. And a fourth is 2/4, and then 3/4. 3 pi over 4. 4/4 is 1. 5/4, or 5 pi over 4. And then 6/4 is 3/2. And then 7/4 would bring me back here. Okay, so then these next parts are going to be actually breaking it down into sixths. So this is going to be pi over 6. And then from here to here is another sixth. So that's 2/6, which is also 1/3, or pi over 3. And then another 6 would be 3/6, which is a half, which is what I have there. And then I have 4/6, which I could reduce to 2/3, or 2 pi over 3. And then once I'm there, then another sixth would take me to 5/6, which I can't reduce. So 5 pi over 6. 6/6 is pi. 7/6 would be 7 pi over 6. Then another sixth would be 8 pi over 6, which is going to reduce to 4 pi thirds. And then, so that's 8, and then 9 sixths would be 3 halves. 10 sixths would be 5 pi over 3. And then 11 sixths. And then finally, 12 sixths would be 2 pi. So there's all of my angles and radians. And those are the key ones that we're going to be using most of the year, right? There are other ones, but these are the ones that are going to come up the most commonly, and they're also the ones which are going to work out with our 30, 60, 90, and 45, 45, 90 special right triangles. So how I can find the coordinates here. So on this first one, if I take my triangles, the one which is going to match up there is going to be my 30, 60, 90. Because really, my pi over 6 angle is the same as a 30-degree angle here. So now what's the coordinates of that particular point? Well, the x coordinate is right here. That's the rad 3 over 2. And then my y coordinate is going to be 1/2. Sorry, if I haven't mentioned, copy and draw this down, sketch it in your notebook. This is going to be a good thing to have as far as notes go. So it doesn't need to be perfect, but just try and get a good estimate of what we have here. So then I have that point that corresponds to it. Now this one doesn't work here. Well, I could do, well, it's the right length, but this doesn't really help me with the x and y coordinates. But the one which does is going to be my 45, 45, 90. If I put that in there, now I have my x and my y coordinates pretty obviously there. So that's going to be rad 2 over 2 for my x, and rad 2 over 2 for my y coordinate. And then again, I can't use it here, but I can go back to my 30, 60, 90. As opposed to using it like this, if I turn it over, I can use it like that. So now it's a 60-degree angle there, which gives me an x value of 1/2, and my y is now rad 3 over 2. Okay. Now I don't need my triangles for this one here because it's just a vertical line, right? My x value is 0. My y value is 1. Likewise, over here it's the opposite. It's 1, 0. Over here, I'm going to want to use my 30, 60, 90, and I'm going to want to do it like this. Right? So that is showing me, well, my x value is 1/2, but hey, I'm going in this direction, so that's actually a -1/2. So this would be -1/2. My y value is still positive, so it's rad 3 over 2. Okay, and then over here, this is where I want my 45, 45, 90. Put it right there. So that's going to be negative rad 2 over 2, and then positive rad 2 over 2 for my y. So there's that point. And then for this one, I want my 30, 60, 90. I'll do a little bit of flipping that over, and it'll look like that. Okay, so that's going to be negative rad 3 over 2, and then up 1/2. And then over here, this is at -1, 0. So hopefully we're already starting to see some patterns here, right? How do these compare? How do these compare? How do these compare? Right? It's I'm getting the exact same points, but over here, all of my x's are negatives, whereas here everything's positive, right? That's because if you think about it, this is the exact same shape. For that one, I used that. And the only thing that changed over to this side was now my x value is negative. So let's make some predictions. If I go down here, my first one is going to be the same as those last two. It still has the same x and y distances, but now I'm negative and negative. So this one should have the same coordinates as this, but they're both negative now, and lo and behold it is. Negative rad 3 over 2, negative 1/2. At that point. So then my point here, same as this, but now both negative. So this would be negative rad 2 over 2, negative rad 2 over 2. And then here, this is going to be the same as this, but now both negative. So negative 1/2, negative rad 3 over 2. And over here, just going 0 on my x and negative 1 on my y. That one's kind of easy. And back over here, these and these are going to correspond, right? But in this case, here, it was half and then rad 3 over 2 both positive. If I go down here, still half over, but now it's down rad 3 over 2, so that's going to be negative. So I would have my x coordinates positive 1/2. My y is now negative rad 3 over 2. So I'm going to be getting the exact same thing as I had here, but now my y value is negative. So this one would be rad 2 over 2 negative rad 2 over 2. And then here, rad 3 over 2 negative 1/2. There's all of those points. So I'll zoom out just a little bit so you can hopefully see all that in one go. There we go. Okay, so you can see all of those points. So make sure you have those labeled on your own notes there for us. Okay, so we've done that. Now let's go through what can we do with this portion now. Okay, so hopefully we see some things that are called reference angles here, and we already kind of found those patterns. So if I hop back over to this pi over 6, this is my reference angle for this one here, this 5 pi over 6, and 7 pi over 6, and 11 pi over 6. Why it's the reference angle is it's the kind of positive one we're more used to and kind of like more, but it gives us the exact same coordinates as these ones, but these three just have different signs as opposed to the ones here, right? And then likewise, pi over 4 would be 3 pi over 4, 5 pi over 4, and 7 pi over 4. And then pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now, that also makes sense to say, hey, those all have the same denominator. True. And that's another reason why it's really easy to kind of keep in mind those reference angles. So if I know these ones, I really know all of them, right? Because my over 6 are always going to be in this pattern here. But all that's going to change is the positive and negative signs. If I know my over 4s, same for all of them, but just different positive and negative signs. And then my over 3s, same for all of them, but again, different positive or negative signs. And then the vertical left, down, and right are all going to be pretty easy. It's just 0, 1s, and stuff like that. So we're going to focus on just the reference angles, those three there. So really, you only need to try and remember those three, because the rest of them you can figure out from there. Okay, so then we want to talk about what's called a coterminal angle. So coterminal means co as in cooperative, they kind of share or they are together, right? And terminal meaning where they end or where they stop. So a coterminal angle would be, like we already have one pair here, 0 and 2 pi. Those are two different angles that stop at the same point. So 0 as in I go nowhere, and then 2 pi as in I go all the way around. And back here, they're coterminal. They both end at the same point. So how about pi over 6? Well, I could go here, but I could also go in the negative direction. I could go all the way around here and then stop here. So that would be a negative 11 pi over 6, because it's this distance, but in the negative direction. So a negative pi over 6 sorry, negative 11 pi over 6 would be the same as pi over 6. So those are coterminal. Another way that we could do it is we could go one full circle and then a little bit more. So one full circle would be 12 pi over 6 plus one more pi over 6 is 13 pi over 6, has that same coterminal angle once again. So keeping that in mind, let's take a look at number 44. So here A, B, C, and D. What would be a coterminal angle on the unit circle we just drew with each of those angles? So use your unit circle and those, pause the video and try and find the coterminal angle with all of those. Go for it. Okay, so now that you've done that, let's go over those. So negative pi over 4, well, pi over 4 is this distance here. So I want that distance, but in the negative direction. I would be at 7 pi over 4. There we go. My second one is 7 pi over 3. So 7 pi over 3 is more than 2 pi, right? 6 pi over 3 is one full circle. And then an extra pi over 3 beyond that, I'm here at pi over 3. Part C, we have negative 5 pi over 6. Well, 5 pi over 6 is this distance. So I want that distance, but in the negative direction. I'm going to end up here at 7 pi over 6. Okay? And then on D, 11 pi over 4. Well, that's more than 2 pi. So 8 pi over 4 would be one full circle. So there's 8 pi over 4. And then I have 3 pi over 4 left over, so I go 3 pi over 4 more. That's where I end up at 3 pi over 4 as my coterminal angle. So those are going to become more and more important as we kind of go forward. But for right now, as long as you're able to kind of get a decent idea for what your unit circle has on it and how to kind of find those coterminal angles, that's what we really care about for right now. So note-wise, this is the graphing form. We went over this a bit the last time. We have our A, our B, our H, and our K values. Make sure you kind of know what each of those four things do. And then we have the locator point, which is kind of the point which we're going to reference and then move to kind of figure out those shifts. So things you should be able to know how they do. Horizontal shifts are done by the H, vertical shifts are done by the K. Vertical stretches or compressions are done by the A. Horizontal stretches or compressions are done by the B. And if I want to get a vertical reflection, that's going to be making my A negative. If I want to get a horizontal reflection, which we haven't covered a lot yet, that's when I make my B value negative, and I will get that. Okay, so to close off here, just real quick, think about what method you use to determine the angles and the coordinates. How do you figure out those with those triangles and the circle? Just try and rethink about how those all relate. That's the big crux that I want you guys to get today. And then with that, here is our homework for 221. We're going to be doing 48 through 55. So I will talk to you guys next time.